Should be brighter than that. Greetings, Banana Man here. No, wait, that's something else. The Astro 30 here. This is an LED E27, which is Edison screw light bulb, and it's fouled in an interesting way. It's only half the brightness it should be. If I turn it off, you get that sudden burst of brightness. So something's gone wrong with the circuitry inside this bulb, and I'm curious to find out what it is. And at one point it was pulsing, but that was about 2 years ago. I've had this bulb knocking around for 2 years to a video on it and just never got round to it. So I'm going to take it out. I'm going to carefully open it. And by carefully opening it, I mean I'm going to take a screwdriver and hack at it until it comes apart. I could cut it, but can't be bothered. It's made by Philips. It's a 14 watt, 6500K, 1400 M, 110 MA, made in China. Please do not dispose in a bin, which I'm going to when I'm finished. And a bit of you bastard. And a bit of screwing around later. We're in like Flynn. Now I've got to try and get this to come out of the housing. That's going to prove to be challenging because of this rubber gasket they've got here as a seal. So let me work at this a bit more with a screwdriver and we'll see if we can get the circuit board to pop out. But quite an interesting layout array of LEDs there. It's nice. Actually, these look like little clips that I need to bend out of the way. So I might try doing that first. I don't know if that did anything. It's actually, well, looks like it's siliconed to the body here. So this may again prove challenging to get it to separate because there's a lot of silicon there. I don't want to damage the board too much. Alright, I'll see if I can get this reflector out. It's actually silicon, not rubber. But anyway. Interesting circuitry in there. I'll have to disconnect these wires very carefully. And by carefully, I mean cut them. Right. Well, don't need that anymore. Okay, so really great way of just having a capacitor just hanging up in the breeze. That's a 4.7 microfarad 400 volt. So this is using a basic switch mode supply. That is kind of interesting to be honest. Normally these use capacitive droppers. That is, you use the reactance of a capacitor, a large 240 volt or 250 volt device, and the reactance of the capacitor actually drops the voltage. But this is switch mode. I don't know if that capacitor has a charge on it still. I'm not planning on plugging this back in again. If I could find where the two capacitor leads go, underneath this SMD, which is a pain in the ass. That's actually its bridge rectifier, but there's no charge on it. I can't really see any physical reason why it failed. Actually, if we look closely here, there appears to be a crack in the PCB near one of those legs of that bridge rectifier. That could be the whole reason why this doesn't work. Huh. I've never seen that before. Well, that's what's inside one of these things. It's not very interesting at all. It makes for a short little video. And I don't think I'm going to go any further with that because there's obviously got a crack in the circuit board. So that'll be the reason why it doesn't work. Here's an SMD IC. Not sure what that is. I can't even read a number on that, if there is one. It's probably a control IC for the switch mode side of the power supply. I'm interested to know what the capacitance of this capacitor is now. According to the meter, which you can't see, it says 4.3 microfarad. Yeah, see, 4.359. This thing is junk. So, anyway, let's have a look inside that bulb. I'll throw it in the bin now. Anyway, I'm the Astro 30. If you enjoyed this video, please remember to like, comment and subscribe, and you can always follow me on Facebook. The link is in the description as usual. Anyway, this is the Astro 30 saying, don't mess around with stuff if you don't understand what you're doing, because you can electrocute yourself.